third standard lesson on geometric sequences. So last week we spoke about arithmetic sequences, and then we spoke a little bit about arithmetic summing, so series. So today we're going to talk about geometric sequences. All right, so just some notes for us to go through in the beginning. So when we talk about a sequence that is geometric, we're talking about a sequence where there is a constant ratio between consecutive terms. So in other words, if I have a look at the numbers that I've put on the board now, I've said 2, 4, 6, 8 is a geometric sequence. And the reason that it's geometric is because each time when I go from 2 to 4, oh, I don't know if you can see that, maybe I should rather write in a darker color, from 2 to 4 to 6 to 8, there's not, sorry, that's not correct. Hang on a second. There's not supposed to be a 6 here.
Yeah.
I don't know what I was thinking. Hang on a second. There's not supposed to be a 6 here. All right, so let's put the 4 in the middle. Okay, so as we go from one term to the next, we are having to multiply. From one term to the next, we are having to multiply. Right, so sometimes we're multiplying by a whole number, sometimes we're multiplying by a fraction. So for example, we could have something like this. I could have 128, 64, 32. All right, so when I go from this term to this term, I'm multiplying by 1 over 2. When I go from this term to this term, I am multiplying by 1 over 2. So there's not a constant difference anymore. What you will find, matrix, is that there will be some questions that they ask you in tests and exams where they do not tell you whether the pattern is geometric or arithmetic, and it's up to you to figure it out. So that's what you have to look for. Either there is a constant difference between terms, in which case it's arithmetic, and then you must use the appropriate arithmetic formulae, or the sequence is geometric, and then you have to use the appropriate geometric formulae because there is a constant ratio. All right, so how do we calculate R, the constant ratio? As follows. So it's always the next term divided by the previous one. Okay, so very, very important. That's something that a lot of matrics seem to forget. So it's either term 3 divided by term 2, or the other way you could write it is term 2 divided by term 1. So as long as it is a consecutive next term divided by the previous term, it's fine. I mean, even if I wanted to say that R is term 9 divided by term 8, that's fine for me to say that. Okay, so here for me to work out the constant difference in this first pattern over here, I would have said 8 divided by 4, or I could have said 4 divided by 2, and that's where I would have got my 2 from. In the next sequence down here, in order to work out what R is, I would say 64 divided by 128. Or I could say 32 divided by 64, which means that my ratio is a half. Okay, so that is something that's really important for when you work it out. Remember, it's always the next one divided by the previous one if you want to calculate the value of R. And then you'll see later in this lesson, we're also going to use this formula here as well, where sometimes what they do is they give us an unknown letter in a geometric sequence, and then they want us to calculate the value of the letter. So we have to use this equation in order to calculate the value of the letter. So Tn over Tn minus 1 is just another fancy way of saying, like, term 3 over term 2 is term 2 over term 1. Okay, so these things are not on your formula sheet. So these are the theory things that you absolutely have to know. Like with arithmetic series and sequences, the first term of the series or sequence is also the letter A, and the general term of a geometric or exponential number pattern is given by the formula Tn equals A R to the n minus 1. Okay, so like with an arithmetic sequence, A represents the first term. So A is always the first term, irrespective of whether it's arithmetic or geometric. Then we have R to represent the constant, or common ratio. N is always the position of the term or the number of terms, and Tn is the value of the term. Okay, so the value of the term in the nth position. All right, any questions so far? Any comments? Everybody good? All right, so let's go and have a look at the first example. All right, so here we have to consider a geometric sequence, and the sequence goes 2, 3, and then it goes 4.5, and then it goes 6.25, so 6,25. They want us to determine a general formula, a formula for the general term of the sequence. So very important matrix, you must read the questions. All right, you have to read what the question is saying to you. Don't just go and look at the numbers, right? Because in this case, they've told us here that we are talking about a geometric sequence, right? So straight away, when we see the word geometric sequence and they want us to determine a formula, we need to start thinking about Tn equals AR to the n minus 1. Okay, so when they want a general formula, what they're really asking for is the value of A and the value of R. All right, so now let's go and have a look at what we've got here, and I'm going to ask you guys, because I'm doing all the talking. Antonio, can you tell me what the value of A is in this case, please? Antonio, can you unmute yourself, or you can pop it in the chat? What's the value of A?
It's 2.
It is 2. Yes, perfect. All right, so A is equal to 2. Excellent. All right, now we need to work out the value of R. Remember, we either need to say term 4 divided by term 3, or term 3 divided by term 2, or term 2 divided by term 1. All right, so Caitlin, what do you get for R? Caitlin, do you want to unmute yourself? You can tell us what you get for R, please.
I'm sorry, I'm still like getting used to geometry because we just started that in class and we didn't have a proper math lesson. So yeah, sorry.
That's okay. No, it's okay. So for any geometric sequence, we're always going to calculate R by taking the next term and dividing it by the previous term. All right, so if you want to, in this case, you can see that the first term is 2. All right, the second term in this case is going to be 3. All right, so that means that R is going to be 3 over 2. Okay, and you would find exactly the same thing. If you would put into your calculator and you said 4.5 divided by 3, you should get 3 over 2. And if you say 6,25 divided by 4,5, you should get 3 over 2. All right. So now that we know the values of A and R, this is how we write it. So we write the 2 in front for the A, and then the R we often put in brackets, okay, because it has this exponent of n minus 1. So I'm going to pop it in brackets. 3 over 2 is our base, n minus 1, like so. All right, so there we've determined a formula for the general term of the sequence. Okay, so that formula will allow us to calculate any term in the pattern. And we could, if we knew the value of a term, we could also use that general formula to work backwards to calculate n, or the term number. Right? When they say to us, find the value of the 15th term, this is what they want us to do. They want us to sub 15 in the place of n. All right, so when we're finding the value of the 15th term, we are working out the value of term 15. Okay, so subbing in here, 2 times 3 over 2 to the power of 15 minus 1. You don't have to write this step. I'm just writing it for you. So we all know that 15 take away 1 is 14. So there we go, guys. AR to the n minus 1. And then we would pop that into our calculators. And as it turns out, the answer to that is going to be a really, really tiny number. What do you get, Valerie? Maybe round it to 4 decimal places. Did you get an answer, Valerie?
She responded in the
yes,
chat.
yes, okay, she's in the chat. Oh, I see what I did wrong, Valerie. You know what? I think you're right and I think I'm wrong. Hang on a second. Anybody else get the same answer as Valerie? It's not a tiny number.
I got 583, but it's comma 8585, not
yes.
8582.
I also get 8585. Okay, but it's fine, Valerie. That was probably just a little typing mistake. Hey, so 583. Jolene got the same. Awesome. So if we round that off to, what is wrong with me today? Let me just write that a little bit better. Comma 86. There we go. Okay, so Ntebogang says the same, and Jolene says the same. Yeah, awesome. All right. Okay, so now what we want to do is we want to go down to our traffic lights and let's go and see if we can do the first question. Okay, so if we have a look at question number 1, matrix, either do B or C. Don't do both. All right, and then we're going to give you, I think 3 minutes should be more than enough. You're just going to determine the general term for the sequence. Okay, what I forgot to do here, guys, but hopefully you know this. Sorry, just put the nth term. There's our formula. Okay, can you give us a thumbs up when you finished? And then we know that you're done and we can move on. Okay, so Jason's put an answer in the chat for us. Awesome. Thank you, Jason. Okay, cool.
Valerie is done as well.
All right, cool.
Jolene is done. Yeah. Trish. Jamie.
Ntebogang is done. Okay, cool beans. All right, so everybody's finished. Well, almost everybody.
Oh yeah, most people. Okay, guys, I'm just going to explain the general term for B quickly. So to find the common ratio, you either say term 3 divided by term 2, or you're going to say term 2 divided by term 1. And if you do that, you'll find that R is equal to 4. So you either say 32 divided by 8 or 8 divided by 2, and your R is 4. And then you substitute it into the equation we have on the right on your screen there. So Tn is AR to the n minus 1. So then your A is your first term. So Tn will be 2 and your r is 4 to the power
See.
of n minus 1. So that is the answer.
There
for
we
B.
go.
There we go.
All right, so if you got that, then that's perfect. Anybody do the orange one? Siatemba, did you do the orange one? Or do you want to ask a question? Go for it.
I did the orange one.
You did the
And
orange
Trish.
one.
Yeah.
Okay, all right, perfect. All right, so there we go. There's the answer to the orange question. Okay, so a little bit more difficult because it had negatives in it. Did you get the same answer as me, guys? A is minus 2 over 3, R is negative 2. Yes, okay. All right, any questions? That was easy enough.
May I just say something quickly?
Of course.
With C, please take note that that negative stays inside the bracket. Don't make the mistake and multiply it with the negative outside, because the exponent will determine the sign at the end. Because if you have an odd exponent, then it's still a negative. But if you have an even exponent, then that number in brackets will become positive. So that negative stays in the brackets. Do not multiply it with the negative that is with 2 over 3. Thank you, Liz.
Lovely. Thank you for pointing that out. That's perfect. And we're actually going to talk a little bit more about that now, because we need to speak about exponential equations before we can actually go on and talk about any of the other kinds of examples that we've got here today. All right, so I just wanted to revise these with you. Okay, Adam's asked a question, sorry. Isn't the R for C minus 3? Okay, Adam, let's go back and go and have a look. What did I write, Adam? Yes, because, sorry, I don't know what I was,
I
sorry,
also
silly.
didn't see what
It's,
you...
look, negative 6 over 2,
Yeah, that's negative,
negative
3.
3. Sorry, Adam, that was a mistake that I had made. Thank you for pointing that out. Okay, so over here, sorry.
Oh, negative 2.
Oh, hang on a second. Did I write this down wrong? So it was minus 2.
Yes, the sequence is wrong.
Oh, okay. Hang on a second. There was supposed to be a 2 there. All right.
Yes.
So sorry, Adam, the reason I got this wrong is because when I copied it down over here, I wrote 3 there instead of 2. So it was supposed to be negative 3. Quite right. So let's just get rid of that. Thanks. And guys, if you see that I have written something like that that's incorrect, please don't be afraid to say something. I also make mistakes just like everybody else, so I'm not precious about that at all.
Trish's hand is up.
Sure. What's your question?
Trish?
Do you have a question, Trish?
Oh, okay. She doesn't have one. It's in the
You
chat.
don't have one. Okay, maybe it was just for the
yeah.
I also did the orange one. Okay, so let's go back and have a look at some exponential equations, all right? Because you're going to be required to be able to solve exponential equations in order to answer the questions in this section. All right, so what I've done is I have cut out an example of some of the kinds of equations that you're going to see when the base is a positive number, but then something really strange happens here, something that we've actually never seen before in our CAP syllabus, is that the base can be negative. So if you have a look at the equation on the left, if they ask us to solve for n and 2 to the power of n is equal to 64, what they want us to do is they want us to write 64 as 2 to the power of something. All right, so we're going to use the base that they give us as the guide onto how to write the number. All right, so in other words, we need to write the number with the same base because we have to equate the bases in order to equate the exponents. All right, so this step over here is called equating the bases. And once I've made the bases the same, I can then go and equate the exponents. All right, so in this case, n would be equal to 6. Now, very important, this is what Katlego was talking about, right? If you have a geometric sequence and you have a base that is negative, all right, if the exponent is positive, then your number is going to, is even, then your number is going to be a positive number. Okay, and the reason for that is because we can group together the negatives in pairs. So if I've got 6 negatives like that, if I group them together, that makes a positive. If I group them together, that makes a positive. If I group them together, it makes a positive. So any number that is negative, if it's raised to a power that's even, you're going to get a positive outcome. When you equate the bases, though, you must make sure that they are identical. So if they've given you -2 to the n on this side, you must write -2 on the other side as well. Okay, otherwise they will deduct marks. Are there any questions? Does that make sense to everybody? Thumbs up, thumbs down. Thumbs up. Thanks, Ntipocheng. Everybody else? You okay? Making sense?
Jamie gave a thumbs up. Jolene,
Okay.
Miso. Okay.
All
Talia.
right. Okay, so our prior knowledge of how to solve exponential equations, Adam says, yes, it does. What about the log function on a calculator? Yeah, I suppose you could do that. But the thing is, at the end of the day, Adam, there are certain things that you have to show if you want the marks. Okay, so you can't do all the work on the calculator and just write down the answer. So when it comes to a situation like this, the minimum that you have to show is that you have equated the bases and then you've worked out what the answer is. I doubt that you'll get a question that's as easy as A and B to solve. You know, the kind of things that you're going to be doing is some more difficult stuff like this, or even let's get rid of the block entirely, something like that. Those are the sort of equations that you're going to be solving. All right, so if we have a look at C and D now, it's the same question, except that in D, you can see the base is negative. All right, so again, it's just there to show you that if your base is negative, and they've made a mistake here because there's supposed to be a negative in there as well, that you are required to write the base as a negative. That doesn't really teach us anything else. If we have a look at question D, right, they're asking us to work backwards and calculate the value of n if they've told us that this is equal to 1 over 128. So the very first thing that we need to do is we need to divide by this value over here on both sides. Now, what they've done is they've multiplied both sides by a half. Right? That's exactly the same as dividing by 2. So if you divide by 2, it's exactly the same as multiplying by 1 over 2. So what you could do in this next step, you've got 1 over 128 equals 2 to the minus 1 over 2 n, right? And we're solving for n. Divide both sides by 2. So that gives us 1 over 128. And when we divide that by 2, we end up with 1 over 256. Okay, so now you would be required to show that. So now minus 1 over 2 to the n. Now, something that you can do on your calculator is if you do not know what 1 over 256 is as minus 1 over the 2 to the power of, you can do this on your calculator, but you can't put in a fraction. So on the calculator, you press 256 and then you press equals. And then you press shift and then you press fact. And the fact button is on the same button as the degrees, minutes, and seconds that you would use in geography. So it's a open circle and then a colon and then 2 colons next to one another. Okay, so if everybody tries that, so you press 256 equals, shift fact, you get 256 is 2 to the power of what? Wonder, what did you get? 2 to the power of? Yes, perfect, Jamie. Well done, Sukupe. Yes, Candace. Yes, Jolene, 100%. Okay, so it's 2 to the power of 8. Now, this is the part that the calculator can't do, okay? The calculator can't think, okay? It can only work out the things that you tell it to. You have to think, all right? So you thinking now, how am I going to answer this question? This is your job, all right? You have to write it with the same base, all right? To the power of 8, okay? And because we have a negative base, and we have an even exponent, we have a positive number. Okay, so over here, minus 1 over 2 to the power of n, and now we've equated the bases, we can equate the exponents. Okay, matrix. So very, very important. You will always get a mark for equating. You'll get a mark for making the bases the same, and then you can get a mark for the answer. Okay, any other questions, comments? Everybody happy? Okay, and we do see this negative base come up quite a lot, so yeah, just be aware of it. Some other stuff that we need to know when we are solving equations with odd or even exponents. If you have r squared, so you've got a even exponent, don't forget your answer can be plus or minus. Now, matrix, that doesn't just apply to r squared. It applies to any exponent that is an even number. So if you have a look down here in example D, r to the power of 4 equals 16, okay? Again, I mustn't forget the plus minus. All right, so that's something where we often get caught out. When it comes to exponents that are odd, the same rule doesn't apply. So if we look at B, r cubed is 27, the cube root of 27 is 3. If we look at C, r cubed equals negative 27, the cube root of negative 27 is negative 3. So there's only one solution in that case. All right, but if r squared or r to the power of 4 or r to the power of 6 or any even number, any multiple of 2, remember your answer could be positive or negative. Okay, so that's something that we tend to forget. Okay, are there any questions on that? Anyone got anything to say? No, we're all good? All right, let's barrel on again. Okay, so let's do another example, and then it'll be time for you guys to go and try another question in the traffic lights. Okay, so in example number 2, they've told us which term, asked us, determine which term in the sequence 4, 12, 36, 108 is equal to 8, 7, 4, 8. So matrix, can you see here, they haven't told us what kind of sequence this is. They haven't said anything about whether it's arithmetic or geometric. So that would be the first thing that we would need to establish, right? So is there a constant difference? If I say 108 minus 36, is it the same as 36 minus 12? Definitely not. Okay, so now I need to go and test. Is there a common ratio? So let me go and have a look. All right, so if I take 108 and I divide it by 36, I'm going to end up with an answer of 3. And I would get the same thing if I took 12 and I divided it by 4. I would end up with an answer of 3. So now I've established this is very definitely a geometric sequence. All right, so a geometric sequence needs to be written in terms of A and R. Yes, Talia, I don't know if I've said that correct. R is equal to 3. Okay, so when they've said to us determine which term in the sequence, what letter are they asking us to calculate in our formula Tn equals AR to the n minus 1? Which term in the sequence implies calculate what? Let's ask Tiana. Do you know what it means? When the question says determine which term in the sequence, what are they asking you to calculate, Tiana? You can unmute yourself if you want to, or put something in the chat. Okay, so Talia has put an answer there. Okay, let's just see what Tiana says.
What's the question?
They want you to figure out which term 8,748 is.
Exactly. So if we have a look at the different letters here, Tiana, we can either calculate Tn or A or R or N. So which one of these letters are we calculating? There?
Ma'am, we're figuring out N.
Perfect. Perfect. That's exactly what we're calculating, Tiana. We're calculating it. See, Atemba, you raised your hand. Do you want to ask something?
No, I don't know. Sorry, it was a mistake.
You just wanted to answer the question. Okay. So the reason that I emphasize certain things is because these are the mistakes that I see my own matrix making on a regular basis. All right, so a lot of the time they don't read the question, they just look at the numbers and then they try and figure out something, all right, without reading the question. So that's why I'm just trying to emphasize with you, you need to read the question, you need to understand what they're asking you for, all right? So because they're asking you in English language, and that always translates to a variable that you're solving for. All right, so in this case, the question determine the term means solve for n. Okay, so that means we need to take this 8748 and pop it on the left-hand side, because that's a Tn, all right, which term in the pattern is equal to this. The value of A is 4. The value of R, as we've established, is 3 to the power of n minus 1. No problem, Ashay. We're glad that you can join us. All right, so now the very first step, okay, as we discussed previously, I'm now going to ask Andile. Andile, what is the first thing that we need to do to both sides? What's the first thing we need to do to divide by 4? Perfect. Okay, so we're going to divide 8748 by 4. Andile, what do you get? You can just pop it into the chat again. Excellent. Well done. 2187. I quite agree. Do you agree, Katlejo?
Yes, I got the same.
Okay, you got the same. Okay, now the next step in the process, Jolene, what do I need to do now? What's the next step in the process, Jolene? You can pop it into the chat if you want to, or you can unmute and talk. Okay, and you don't know, that's okay, no stress. Let's see if Andile knows. Andile, what's the next step in the process? Okay, so equate the 2137 with the right-hand side, sure, but how? How are we going to equate it? What do I need to do specifically with that 2187? Make the bases the same. Good, yes. Okay, make our answer exponential. Yes, lovely. Okay, so in other words, this number, the number is 2187. This number, yes, there we go, Talia. Yes, indeed, Siyabonga. Okay, so we press shift fact on our calculator, and as it turns out, 3 to the power of 7, that's a 7, guys. Okay, is equal to 3 to the power of n minus 1. Okay, Jolene, so when you get to this stage over here, you have to make the bases the same. Okay, so make the bases the same. I'm just going to write that in here for you. Okay, using the shift fact button. Okay, and now that you have equated the bases, you can equate the exponents. So equating the exponents comes down to writing, well, n minus 1 is 7. So therefore, n has to be equal to, add 1 to both sides, n has to be equal to 8 in this case. Okay, how do you feel about that, Matrix? Does that make sense? Is there anything that you'd like to ask? Anyone got any questions? Sure. Okay, so you give this a try. So we're going to go down here to our traffic lights again. Okay, and again, let's leave number 2 for now. We can always come back to that, but let's go and have a look at question 3. Okay. You can either do 3A or you can do 3B, right? Do one, don't do both, right? If you want more of a challenge, you are welcome to do question B. I'm always going to do that. I'm always going to give you something that's a little bit easier if you're not feeling confident. And then for the people that are feeling confident, there's always going to be a challenge. So I encourage you, if you are feeling confident, to challenge yourself. So either try 3A or 3B. Okay, we're going to work out the term in the geometric sequence that's equal to 4374, or the number of terms in the pattern where the nth term is 192. All right, so matrix, you've got 5 minutes. And please, if you have any questions, just ask us. And then we'll talk about our answers together afterwards. Oh, wow, so coupe, that's great. Oh, and Talia as well. Very nice. Did you guys do the orange one or did you do the red one? So coupe, Talia, orange or red? Cool, Jamie. Orange. Okay, so Talia, you're going to try and do the red one as well. That's awesome. So coupe, maybe try and do the red one too. We'll just wait and see if everybody else is finished. And then we'll talk about the answers. Good, Jolene. Okay, so guys, when you're done, just give us a thumbs up and we can go through the answers. Awesome, Jamie. Good job. Okay, Sade, very nice. I hope I said your name correctly. Is it Sade? Cosejo. Good, Cosejo. Oh, good. I'm glad I said it well. Ntipogeng, good. Nice. Chiamo is also finished. Good, Matrix. Hopefully this is making sense. All right, so we're just going to wait 1 more minute and then we'll go and have a look at the answers and then we can move on to the next thing. Okay, so Coupe, you're done. Okay, so let's go, and Masha is also done. All right, guys, so let's go and have a look at the answers. I hope I haven't made any mistakes. If I have, my apologies, but please point them out to me if I have. Okay, so 3A is over here. All right, so you should have made Tn equal to 4374. You should have had A equal to 2 and R equal to 3. Am I correct? Hope so.
Yes, yes.
Good. And then you would have divided both sides by 2, equated the bases, and then equated the exponents and worked out that n was equal to 8. So out of the people that did the orange question, can you give us a thumbs up if you'd got it right? Just so we can see how you're doing. Good, and Tebogang. If you did orange, did you get it right? Oh, look at all those lovely thumbs ups. Well done. Miso, Jolene, Sukupe, Andile, lovely. Candace, Nolene, Shode.
Nashe, there's a lot of them.
Okay, oh, that's awesome. Very nice. Okay, and then the next one. Okay, let's go. Whoopsie. Sorry, my board's jumping around all over the place. Let's just move over. And there we go. All right, so if you had done the red one, here is the answer in red. Let me just move it over slightly. Okay, so I hope I didn't make any mistakes. I said that A was -3/8, and I said that R was -2. Did you get the same answer as me?
Yes, I did.
Okay. So matrix, the first thing that you would have done is divided 192 by -3/8. You just do that on your calculator. When I did that, I got -512. And that makes perfect sense to me, okay, because I can see here I've got a negative base. So I know that I'm going to be writing my answer as -2 to the power of something. And again, can you see here, this is what Katlego was saying to us earlier, when we've got a negative base and we've written it to a power that is an odd number, we are going to get a negative answer. All right, so if we took a base, for example, -2, and we wrote it to an exponent that was even, we would end up with a positive answer. So in this case, positive 1024. All right, so that's something really important to note going on. So just your marks here, because I think it's always nice for us to know where our marks are allocated for equating to 192, for making the bases the same and working out the answer. The other thing that I haven't mentioned so far, but is also important for you in matric, is that if you sub into the wrong formula, you're not going to get any marks. All right, so knowing the correct formula to use is really what matric, I'm talking about sequences and series now, is really what matric work is all about. Subbing into the formula and calculating in, or whatever it is, that really is grade 10 and grade 11 work. But knowing that the correct formula to use is Tn equals AR to the n minus 1 is really what matric is all about. So yeah, just make sure that you do sub into the right formula. Otherwise, unfortunately, we don't get any marks at all. All right, are there any other questions, comments?
Lee,
Yes.
may I just confirm something? When we are using the shift fact to find the exponents, you do not substitute the negative. Please note, guys, it does not work if you do that. No, it doesn't work.
Yeah, no, it doesn't work. And you also can't do it with a fraction. So in other words, if you have something like we had earlier, so 1/256, if you do that shift fact, then the calculator also says it doesn't work. So you can only put in a positive number.
Yes.
Oh,
so like you just do the 512 and you make the bases the same by putting that negative there.
Exactly. Okay, thanks for mentioning that, Katlego. All right, so let's go back and have a look at our last example. Okay, so this is the sort of thing that they can give us to do matrix. So in example 3, they've said to us that k plus 1, k minus 1, and 2k minus 5 are the first 3 terms of a geometric sequence. Calculate the value of k and hence determine the possible sequences. So what they're suggesting here is that there's more than one sequence, right? So when they ask us to determine the sequence, it's not a very good way of phrasing it, but what they really mean is calculate term 1, term 2, and term 3. All right. So going back to that bit of information that we learned at the beginning of the lesson, the value of R. Remember, R is always term 3 divided by term 2, term 2 divided by term 1. Okay, so in this case, we are subbing into term 3 over term 2 is term 2 over term 1. Right, we need an equation in order to solve for K. All right, and it is our constant ratio or common ratio that is the same in this case. So now we're going to sub in 2K minus 5 in place of T3, and we're going to sub in K minus 1 in place of term 2. In place of term 2 in the numerator here, I'm going to write K minus 1, and in place of the denominator, I'm going to write K plus 1. So now I've subbed in. That's the easy bit. Right? Well, actually, the rest of it's not difficult either. But what I want to know is, what is the next step? Kanye, do you know what would be the next thing for us to do, Kanye?
Cross multiple.
Perfect. Okay, so we're going to cross multiply. All right, so Kanye, that was great. We're going to end up with 2K minus 5 multiplied by this denominator over here, K plus 1. And then we're going to end up with K minus 1, which is our numerator on the right, multiplied by itself. So we're going to give that a square. Okay, now we are doing grade 10, grade 11 maths, all right, where we need to multiply out our brackets. So on the left, we're doing FOIL. On the right, we're squaring a binomial. So on the left, we're going to end up with 2K squared plus 2K. I'm just going to do it the long way, minus 5K minus 5. On the right-hand side, we're going to square the binomial. So we're going to square the first term, multiply the terms together and double it. That's one of the biggest mistakes that we make when we're squaring a binomial. Forget about the middle term, and then we need to square the last term like that. Okay, so now our job is to get everything, because it's quadratic, everything has to be on one side and it has to be equal to 0. All right, so that will be our next step. Let's do that. So we will end up with a K squared over here, because 2K squared minus K squared is 1K squared. Then as far as our K terms are concerned, we've got plus 2 minus 5, which is minus 3, and minus 3 plus 2 is going to leave us with negative 1K, if I'm not mistaken. So that's your K terms taken care of. And now we need to bring the number over. Minus 5 minus 1 is negative 6. All right, and make it equal to 0. All right, so in other words, get it into standard form. Okay, so after we've cross-multiplied and we've multiplied out, we've got it into standard form. Next step is to factorize. Always, always, always. So 2 brackets. In this case, factors of 6 that have a difference of 1 will have to be 3 and 2. 3 will need to be negative in this case to get the negative middle term, and 2 will have to be positive. So either K is equal to 3 or K is equal to 2. So we have more than one solution.
Negative 2, Lee.
Negative 2. Thank you. Yes. Absolutely. So more than one solution. And then what they wanted us to do was go back and go and sub in. So what we would have to do is work out what the pattern is for K equals 3. All right. So our first term, if you recall, was K plus 1. So K plus 1, that would be 4. All right. Then our second term was K minus 1. So that's going to be 3 minus 1, that would be 2. And our third term was 2K minus 5. So subbing that in, we would end up with 1. Do you agree?
3, 6, 1.
2 times 3 is 6, minus 5 would give us 1. So
Yes.
it does make sense, because 2 over 4 is the same as 1 over 2.
Mhm.
Yes, ma'am. Okay, good, Jolene. I'm glad I'm making sense. All right, and then we would also have to work out for where k was equal to -2. So again, we would have to go and sub back in. Remember, term 1 was k plus 1. So -2 plus 1 is -1.
Mhm.
-2 minus 1, because k minus 1 was the second term, so that would be -3. And then subbing in over here, -2 times 2 is negative. That would be -9.
Mm.
Okay. Does that make sense, Matrix? Everybody happy? Any questions? Sure, guys. You sure there are no questions? Okay, thanks, Jamie. I'm glad it makes sense. All right, so now is an opportunity for you guys. Yes, Kosecho, please ask. Oh, thank you, Miso. That's so nice. Thank you. Okay, go for it, Kosecho. What's your question?
Josejo. Oh, there we go.
Okay, so Kosecho says, since k is equal to -2, doesn't it make it not applicable? Kosecho, it could in certain circumstances, all right, but it depends on the question. Just because we get a negative answer doesn't mean that our answer is invalid. There are certain times when our answer would be invalid because it was negative. But in this particular case, there's no restriction on the value of k. All right, they haven't said in the question where k is positive, in which case we would have to disregard k being -2. Or the other thing that I think a lot of students get confused about is when you are calculating n, the number of terms in the series, that can't be negative, also can't be a fraction. Okay, so don't just disregard answers because they're negative. Make sure that you read the question carefully, you know what you're calculating, you understand what it represents, and then you can make a decision as to whether it's invalid or not. Okay, Kosecho, but in this case, it's not invalid. Okay, there was no restriction. Okay, no problem. I'm glad you asked. That's great. Okay, guys, so we've only got 8 minutes left. Let's give you guys another question to try so we can go through this one. All right, so x minus 4, x plus 2, and 3x plus 1 are the first 3 terms of a geometric sequence. Unfortunately here, I don't have an easier question for you. We're all going to have to do the same question. All right, and hopefully it's not really a red question. It's a bit easier than that. Determine the sequence. Now see, Kosecho, look here. Determine the sequence if x is positive. Okay, so now there's a restriction being placed on x. All right, off you go, Matrix. It hopefully shouldn't take you more than about 5 minutes, which will give us enough time to mark the answer and tie up any loose ends. If you've got any questions, please ask Kakecho and I. We're here to help you, and we just want to see you do well and make some progress. Are you okay, Matrix? Everybody managing? You can give us a thumbs up when you are finished. Or pop something into the chat when you're done. Okay, so Matrix, we've only got 4 minutes left of our lesson. We're always chasing against the time. Hopefully you're finishing this off now. Okay, Luke, thank you for your answer. All right, remember the question said determine the sequence if X is positive. All right, so like Koseko was asking us in the previous question, there is a restriction here. All right, so what would you need to do with one of your answers, Luke? Oopsie, sorry. Yes, Sipasihle.
Yes, the videos are available on YouTube and on the Watobe website. So if you're signed up for the Watobe website, then all these videos will be available.
Okay, so we've got 3 minutes left, so let's go and have a look. So I see we've got some different answers there. Luke had 3 as an answer, and I see Michelle is saying that the answer is 8. Okay, so this is what I got when I worked through this question. All right, so I also got 8. All right, so I said term 3 divided by term 2 is term 2 divided by term 1. Correct, Talia. It says that the answer is a positive number, so we have to choose the positive in this case. Correct, Andile. I also got 8. So I cross multiplied and got it into a quadratic form. So I just used the quadratic formula, but obviously if you wanted to factorize, that would be fine. It's very important to note, Matrix, that if you don't use the quadratic, and you can't write down the quadratic formula and not sub into it. You must show that you've subbed it into the formula. You get a mark for this line over here, or the other mark, of course, would be for factorizing. So of course, your other option here, of course, is to say 2x and x, and then your factors in this case would have been
1 and 8.
1 and 8, and 8 would be negative, and that would be
Yes.
positive. Okay, so these are your options. Either you do this or you do the factors. I just did the quadratic formula because I know a lot of people struggle with factorizing. But yeah, you must either show one of these 2 steps. When you factorize Matrix, don't forget you cannot leave off the equal 0. If they give you an accuracy on this line and you leave off the equal 0, they will take that mark away from you. Okay, so isn't that interesting, Luke? All right, so everything else is cool, and then the factorizing is the thing that becomes difficult for us. So yeah, just think about it. Maybe you want to use the quadratic formula. Choice is yours. Okay, just as an alternative. So yes, x was supposed to be equal to 8, and then I think they wanted us to work out. Did they say work out what the sequence was? I think I forgot
The first 3 terms.
Yeah, so we need to work out the first 3 terms. Absolutely. Whoa, Sorry, guys, this mouse is a little bit funny. So we would need to go and sub back in, wouldn't we? All right, so subbing 8 back into our answer. Term 1 was 8 minus 4. So the first term would be 4. Do you
4.
agree?
Yes.
And then the second term would be 8 plus 4, which would be 12.
Mm-hmm.
And then the first term was 3x plus 1. So that would be 4 times.
The second one is plus 2, I think.
Sorry, it is plus 2. Sorry.
Yes.
So this would be 10.
10, yeah.
Sorry. And then this would be
25. I got 25.
Oh, yes, of course, because 3 times, sorry, I'm looking at something else. I'm saying 4 times 3 plus 1. I don't know why I'm doing that, but I'm being silly. Okay, yeah, so it would be 3 times 8 is 24 plus 1 would give us 25. So 4, 10, 25. Okay, so Matrix, how did that go? Thumbs up, thumbs down, how did it go? Are you okay? Making sense? Cool, Jamie.
Okay, we have a lot of thumbs up.
Oh, that's
Tiny,
wonderful.
Jolene, Sukupe, Mashane, Karabile. Talia sent a heart.
Oh, that's awesome, Talia. Thank you so much. And a heart back to you too. I'm so glad that it went well. All right, guys. So that unfortunately is our time over. Our hour always goes by so fast. If it was up to Katlego and I, we would love to stay on and do maths all night with you.